This presentation is a worked example of how we utilized evidence-centered design and learning analytics to develop a game-based training scenario for IARPA, and I've talked about this before in previous lectures. So I suggest that you watch the other presentations potentially first, so that you have a little bit of a background in ECD, evidence-centered design. Briefly, evidence-centered design provides a framework for designing assessments and learning situations that deal with three questions. The first question is basically what complex knowledge skills or attributes you're trying to assess, what behaviors, performances would reveal those constructs, and then what tasks would the learners engage in that would elicit those types of behaviors. So the example I'll talk about here is the Cycles game that we developed. It's a serious game for training and learning, and it was designed and built to teach play learners or those who are playing the game to recognize and mitigate cognitive biases. Now, cognitive biases are when people use shortcuts or heuristics to make decisions, and this can be a good thing because it allows people to not be overwhelmed by their day-to-day activities, but these heuristics can also lead to systematic error and distortion in your decision making, or lead to poor decision making, and this can be problematic in critical situations. The literature describes different ways that people can learn to identify these cognitive biases, and then different mitigation strategies that they can use to prevent poor decision making. The problem is that the traditional model of the classroom has been extremely ineffective in getting people to embody these techniques, and therefore IARPA was looking for a different way to train and teach these cognitive biases that was more situated based, and gaming became something they were interested in because of the situations that you can create in gaming, expose people to ideas and get them to actually practice different behavior within that situated space. The example that I'll use to sort of walk through the evidence-centered design process is one cognitive bias that we worked on, which is representativeness bias. And I'm going to use some of the screenshots from the game to basically give you some background knowledge on what it is, and then we'll look at how we use the ECD framework to put together the different models, and then how we use that to collect data. So representativeness bias is this bias where you rely on irrelevant information rather than more relevant information, which is the chances or the odds of a particular situation in a particular situation. So the game gives you a scenario in the training as you're being trained, where Shannon here flips the coin 3 times and it lands on heads every time. She might think, oh well, it's got to land on tails next time, and she's convinced that it's more likely to land on tails, when in fact it's not. The odds are 50-50 still. So representativeness bias is using this faulty logic and focusing on the irrelevant information of the previous flips in determining what the chances are or what's going to happen next. And in fact, it always will be 50-50 chance for either heads or tails. The play learner is then given a straightforward mitigation strategy for avoiding this cognitive bias. First, they have to identify the chance information or the odds information in the situation, and then they need to ignore the irrelevant information or the previous flips in this example when making a decision. The previous slides are pretty much straightforward teaching, almost like a PowerPoint presentation in the game. But what we wanted to do was use the situated nature of the game to help individuals practice recognition of bias and mitigation of that bias. So we started to use the evidence-centered design model and framework to help us with that, and that's what I'll describe here. So first we defined the domain. We really needed people to recognize and mitigate representativeness bias, or RB. We defined the claims. We wanted the learners to evaluate the situation and then identify the cognitive bias. We needed them to identify when representativeness bias was at play, when chance data was in the situation, and then identify that RB was actually happening in that situation. So we started to think critically about the evidence that we would require. First, we wanted to look at the duration between the time that they entered a situation and their selection. So we wanted to slow down and analyze a situation, see what was going on, see what information was in that situation, and then make decisions. So don't use the shortcuts, don't use your heuristics, but slow down. We also wanted to gather sequential information to see if they were revealing certain things in the situation that would provide evidence that they were grasping this, embodying the mitigation strategy, which was looking for the odds or looking for the chance information in the situation. Then we developed the tasks that we wanted them to do. We wanted first the learner to recognize that representative bias was at play in the situation based on that odds and chance data or information that was in the situation. And then we wanted them to behave differently. In other words, we wanted them to use that chance information to make selections and make decisions. Then we started to develop items of performance, which were the game-based scenarios and situations, which I'll describe here next in the next slides, that provided the player with opportunities to show that they were using these mitigation strategies. So one of the situated items that we developed to get players to experience this is this slot machine's environment. When the player enters this environment, they are asked to pull one of the handles of the slot machine to win, and they're presented with misleading information that could be misleading, such as the wins today information at the top. The thought is that, if a machine is hot today, I'm going to pull that one. That could potentially be a heuristic that you would utilize to win, but it would be misleading. So what you want to do in this situation is slow down, don't pull the slot machine handle, realize that representative bias could be at play here, and to look for additional information. And in this case, it would be the chance information that you would be looking for. Again, some of the evidentiary data that we would be collecting would be the duration from the time you entered into this situation, the time you pulled the handle. If you slowed down and you thought about what was at play here, and you slowed down, then you have the opportunity to reveal the chance information, which is below the wins today information that you see here. So we're collecting that duration information. We're also collecting a sequential information, which would be evidence that you're behaving in ways that would mitigate this particular cognitive bias. In addition, after you've slowed down and you've avoided using your heuristics, and you have the opportunity then to reveal that chance information, we stop you and see if you can recognize and discriminate between the cognitive biases. We ask you a few questions. In this question, we ask, based on the information you've seen so far, what might be going on here, and the correct answer here is focusing too much on appearances or irrelevant information, which is the wins today information at the top of the slot machines. And then we ask you to identify which cognitive bias may be at play, which in this case is RB. You can then go back and reveal the chance information by clicking on it, and then use that chance information to improve your decision making. So in this case, you would pick the third slot machine over from the left, the one that has 1 in 100 chances, so a better chance of winning. That would be the best decision. You were then told that you succeeded at mitigating the cognitive bias or avoiding the cognitive bias, and then you move on to additional game situations where you're given the opportunity to mitigate other cognitive biases. Evidence-centered design is a design framework that allows us to design for situated learning and the collection of digital evidence that John Behrens was talking about in his presentation that I had you watch for this particular module. It's the digital ocean. For example, What you see here on the screen is the log file behind our particular game. It records each event, it records the time, we can get duration information, and it records the sequences between events, happen first, second, third. We can then use this rich data stream to understand student behavior, and then we can use that behavior as evidence that the students who are playing this particular game or are behaving in ways that we are encouraging them to behave, and in this case, behaving in ways that help them mitigate cognitive bias. Using a traditional pre- and post-test measure, our research indicates that our situated behavioral serious game outperforms a traditional training video. And I believe that this is because we get people to actually behave in ways that are indicative of mitigation strategy, and therefore they embody this particular process and learn it more deeply. Some work we want to do in the future in regards to this particular research, we want to use the data streams to detect behavior within game as players are playing. We can detect that behavior and then provide additional feedback. We could also flag instructors, letting them know that maybe a student just isn't engaged in a game or isn't behaving in ways that are optimal. We also want to build more acceptance for the ECD model, the evidence model, so that we get away from, not totally, but maybe get away from the pre-post-test ultimate measure of assessment and use more of the in-game evidence as the assessment model for learning. So anyway, hopefully this gives you an interesting look at the research that I'm working on and how we used the ECD framework to design some of our game elements, and then how we're starting to think about data streams, the digital ocean, if you will, and data streams, and how we use that evidence or use that data to build evidence that our students are learning within these situated game experiences.